Hi Year 12, this is Tuesday's remote lesson for further maths. We've nearly finished the pure part of the course, and before we get to the end I want to make sure that we're completely caught up with all the assignments. We've been doing quite a fair few of them, but one that we haven't quite done yet is the series assignment, which I've got on my screen. So that's all I want you to do for today's lesson and make sure that's finished. And if I attach the mark scheme for you, I'd appreciate it if you could get me a mark out of 50 and send me your marked copy with the score written clearly on the front there. Okay, so to help you out with this, I'm going to give you the notes that you're going to need to help you through the topic, and I'm going to go through all the questions and give you a few pointers just to help you with some of what to do. Right, so starting off then, in this space I'm going to write out the 4 standard results that you need for doing series. So the first 2 of these won't actually be in the formula book in your exam, but the 3rd and 4th of these will. So make sure that you've remembered at least the first 2. So firstly then, adding up a bunch of 1s with our index going from 1 to n. So that's just 1 plus 1 plus 1, n times gives you n. Then raising the power on this term here, so if I'm adding up r's from 1 to n, then that's 1 plus 2 plus 3 plus 4 up to n. That's the formula n plus 1 over 2. Okay, that's the nth triangle number. Then adding up r squares. So adding up square numbers from 1 to n. Hopefully many of you remember this one. This is n plus 1, and then a third term 2n plus 1 over 6. And then finally adding up r cubes. That gives us, if you remember, it's this one squared, quite a nice identity. So you add them up and then square. That's n squared, n plus 1 squared over 4. Okay, so those are the 4 standard results which you're going to be using. Bear in mind as well, for questions like question 2, if your bounds are different from 1 at the beginning and then n at the top, you're going to have to adapt these 4 to end up having to use those. So for this second one, I would begin by writing down what that is as a sum from 1, and then that's going to be all the way up to 2n plus 1 of r. And then what you're going to do is subtract the terms that you don't want to include in this sum, which is all of the terms that start at 1 and finish 1 before this one that it starts at. So n minus 2 is the final term that you're going to subtract away. So that is how you're going to approach question 2, and I think there's some similar questions further on that involve the same method. Okay, so starting from the top, we've done number 2. Number 1 looks like you're going to need to evaluate this left-hand side, evaluate the right-hand side, and then that's going to give you an equation in k, which you can then solve for 4 marks. Question 2 I've already described for you. You've got to show that this subtraction sum equals this given expression over here. Okay, and then question 3, if I move down and get rid of the notes. Okay, so part A is a simple show that. Remember, you need to distribute this sigma into all of your terms so that you can use the 4 standard results. So this will be 6 times the sum of the r's minus 3 times the sum of the 1's. And don't forget that having 3 included in every term in this sum means you're going to have to need to factor out this and add up all the 1's as well. And if that equals 3k squared, you can then work out what k is to satisfy this inequality here. So if you know that this left-hand side is 3k squared, that gives you a nice easy quadratic inequality to then solve for k. Okay, question 4. You're not actually given the values of a and b to begin with for this, but if you work out the left-hand side of this, it's going to be in terms of a and b and n, which will then look very similar to this expression on the right-hand side, which you can compare and then figure out what the values of a and b are going to be. Right, 5. This is very similar to 4 looks like, because you're not told what a and b are, but if you can sum from 1 to 5 and from 1 to 10 and equate them to these numbers, then that will give you a way of figuring out a and b. And then once you've figured out a and b, you can then do part A by finding a general expression for adding up f of r from 1 to n. And then if you can then do that, you can then calculate the sum from 8 to 18 again by doing a subtraction sum because it doesn't start at 1. So this will be the sum from 1 to 18, and I'll leave you to figure out what to subtract away. Part 6 is going to be a show that with a standard result because it's adding up from 1 to n. But remember, you've got to distribute this bracket out before you begin because you can't sum over a product. You've got to first of all expand it out to make the sum of r squareds plus, and then I'll leave you to continue. And that should make this expression on the right. And then once you know that that is the expression, then you can then do 6 to 14, again with one of these subtraction sums as well. Okay, moving on to the next page. A couple more to do on that side. So showing that the sum of the cubes from n plus 1 to 2n equals this on the right. That's going to be another subtraction sum, which you can then use the standard results for. Hence, evaluate r cubed adding from 21 to 40, or that's just comparing to part A, and you can figure out what value to use there. Question 8, it looks like it's going to be some kind of equation to set up where you evaluate the left side, which is an easy one, evaluate the right side, and then you can make an equation in n. And remember that if there's multiple choices for your value of n, then you need to pick the one that makes the most sense in the context of what we're doing here, using series. All right, finally, part 9. And if another show that, so first of all, expand out this bracket, add up all of the terms, show that it equals this right-hand side, and then hence show that adding up from 1 to 2n plus 1 of the same thing makes this slightly different expression here. Well, if we know how to add up from part A up to n, then if that changes to 2n plus 1, then that's all you've got to do for this expression over here, and it shouldn't take too many steps to do that. Okay, so that should be enough to get you going. If you could give yourself a mark out of 50 for these, if I attach the mark scheme, I'd appreciate you sending me a copy of what you've got with the mark shown clearly on the front. All right, thanks, year 12. That's the end of series, and we'll move on to something. We'll finish off vectors on the rest of the week. All right, cheers, bye.